I welcome all my dear students to session 2 of Unit 1 Measuring Instruments. So in the previous session, that is in session 1, we discussed definition of measurement. So it says it is the act or result it is the act or a result of a quantitative comparison between a predetermined standard and an unknown magnitude. So in measurement, so we are using a standard. It may be any type of standards, primary standards, secondary standards, tertiary standards, working standards. It may be any type of standards. So we need a standard compulsorily in the process of measurement. So here you see this is the simple fundamental measuring process diagram which shows this is the unknown magnitude. So the unknown magnitude is nothing but it may be length, mass, time, angular velocity, torque, acceleration, anything. Okay. And also it may be a physical quantity, chemical quantity, mechanical quantity, any type of quantity. It should be a unknown magnitude. So this unknown magnitude will be compared with the standard. So after comparison with the standard, you will get the result in some units. Okay. So finally, we will get the result in terms of units. And the standard should be always predefined or predetermined. Predefined or predetermined means it should be accepted worldwide. For example, simple example. So 1 centimeter is equal to 10 millimeter. Okay, as we know. So we cannot take 1 centimeter is equal to 9 mm or 11 mm. So like that. So that is the simple example. So the standard what we are using should be accepted internationally and it should be predefined. The unit should be predefined. And also we discussed the requirement of measurement. For measurements, there are mainly two requirements. So the standard. The standard used for comparison must be accurately defined and accepted internationally. Okay. And the second requirement is the procedure and the instrument used for measurement must be provable. That is, it must prove its ability to measure quantities more reliably. It should give reliable results. And also the instrument's procedure must be explained. So if the vernier, we use vernier caliper, so this is the procedure to take the results. Okay, to make measurements, so this is the procedure. So first we need to keep the object in between the jaws. Okay, and next what we do, we take MSR, main scale readings. Okay, and vernier scale divisions, and also we need to know the least count of that instrument. And also we have some formulas to calculate the end results. So the procedure and the instrument used for measurement must be provable. So these are the main two requirements. And the mechanical measurements, coming to mechanical measurements, so if the measurements related to mechanical engineering, they are referred to as mechanical measurements. So the simple examples for this is pressure measurement, force, torque, strain, etc. So the measurements should be related to the mechanical engineering. And also we discussed methods of measurements. So here mainly we have direct comparison, indirect comparison method. So always the direct comparison method is less accurate as compared to indirect comparison method. So next, the standard. So the standard is a physical representation of a unit of measurement. So the standard is a physical representation of a unit of measurement. And this standard will be set up and established by an authority as a rule for the measure of quantity. Okay. So see, for example, a meter. A meter is a standard established by an international organization for the measure of length. And also we discussed types of standards. So primary standard, secondary standard, tertiary standard, working standards. So in direct comparison method, so in this method measurement is made directly by comparing an unknown magnitude with the standard. Okay. And also it involves no mathematical calculations, no formulas. So we can directly take the results from this method, measurement method. See, as the name itself says, it is a direct comparison. We are comparing the unknown magnitude with the standard. Okay. But the main disadvantage is it is not always the accurate or best method, because here the maximum human sensing is required. So that is the main reason, but it is a simple method. So the examples are to measure a length of to measure an unknown length of a line. So what we do, we take a steel scale or tape. So here the steel scale or tape is a standard. So we are going to compare the unknown length of a line with that standard. So directly we will get the results. So it may be 10 centimeter, 20 centimeter, like that. So here the 20 is the magnitude, the unknown magnitude. So the centimeter is the unit. And also indirect comparison. We discussed indirect comparison. So see here, indirect comparison. Here we are going to use calibrated system. So the calibrated system means it will be very accurate. It has many units in that. So like sensor or transducer, signal conditioner, display unit. Okay, when we use calibrated system, so we get more accurate results because the human sensing will be less as compared to direct comparison method. Okay, and also here we need some mathematical calculations to get the end results. So these are the topics we covered in session 1. Let us move on to session 2. Session 2. So session 2. So in this session, we are going to discuss about significance of measurements, definition of accuracy, definition of precision, difference between accuracy and precision, with examples, right? Okay. So first, significance of measurements. Significance means what? It's the importance of measurements. So why we need measurements? See, as an engineer, we must have a sound and a thorough knowledge of why a measurement is being made and what information it would give. Okay, so that is the main reason. So why a measurement is being made? First, we need to know why we are making this measurements. So after this measurement, what the result we would get. So next, as a mechanical engineer, you also should know the operational features, limitations and difficulties in the instruments. That is, how a board, for example, see how a board and tube pressure gauge operates. So first, see, before making any measurements, first we need to have thorough knowledge of the instrument itself. Okay, so what are the parts in that instrument? So what is the procedure to take the readings? So how to calculate, which are the formulas we are going to use to get the end results. So if you know the procedure only, you can make measurements. Okay. And the factors which are likely to influence the measuring process. So we need to take care of we need to consider some factors while doing the measurements. Okay. So first, before going to do any measurements using instruments, so we need to know why a measurement is being made. So why we are going to do this measurement. So see, here there are some of the important significance of measurements. We have many significance, many importance, but here I have listed many few. You see, so measuring a measurement process, measurements and metrology is a vast field of engineering. Okay, measurements plays a very important role in engineering field. So see, first one, measurement is a field which involves the measurement of physical, electrical, mechanical, optical, and chemical quantities. So we can take physical quantities. You see, we can measure length, mass, time, okay, volume, like that. So measurement is a field which involves the measurement of physical quantities. So we can measure the length in centimeters, meters, like that. Physical quantity. Okay, physical quantities. Next, electrical. So electrical quantity like voltage, okay, current, power. So these are related to electrical quantities. So coming to mechanical quantities, so we have force, acceleration, torque, shaft power. So like that, we know heavy force, heavy temperatures, high temperatures. So like that. So coming to optical, so transmittance, reflectance. So these are the quantities related to optical. Coming to chemical quantities, so we have like atomic mass, okay, to measure the atomic mass, so like that. So in every field, okay, so we need measurements. So measurements plays an important role in engineering, not only in engineering, it also in trade, like that. So see the second point, measurement is the fundamental basis for all scientific research, design and development, and its role is prominent in many engineering activities. See, measurement is very important for scientific research. Okay, in research, without measurements, they cannot do anything. In design and development, okay. See, there are instruments to control the flight of man-made satellites. Okay. And also a simple example, see, in our homes, we use instruments to control the temperature. It may be the heaters or air conditioners, or to preserve food in refrigerators. Okay. And when we come for automobiles, so the automobiles are equipped with instruments to measure speed and condition of battery, etc. So like that. See, the national security devices and war weapons to utilize instruments for their functioning. In defense and all, for research purpose, they use many measuring instruments. Without measurements, that is very difficult and it is impossible also. We cannot do. We cannot research or we cannot design any components. Okay. So in defense also, it plays a very important role. So third point, so measurements are required for proper and economical design of equipment and processes. Economical design of equipment. Proper and economical design of equipment and process. Okay. for designing. So for designing of any equipment, it is very important. See, for simple example, say when we consider an industry, it has many departments, right? So it will have a design department. Okay, main departments. I'm using related to mechanical engineering. Design department, production unit, production department. Okay, and quality check. So these three related to mechanical engineering. So in design department, for example, we need to produce a gear. Okay. So what the design engineer will do, first he will do the design procedure. Okay, he will design the gear of some dimensions. Okay, so this is the basic dimension. So basic or nominal dimension of this gear. So this is the diameter. This is the basic diameter. So this is the pitch. So this is the thread angle. So first he will design that. Okay, he will give the exact dimensions of a gear to be produced. So this is the design department function. Okay, so he will give the exact dimensions, the pitch diameter, major diameter, minor diameter, thread angle, pitch, flank. Okay, the dimensions of screw thread, the terminology of the gear, and also you will select the material of the gear to be produced. So next, after this design procedure, so this will be transferred to the production department. So the entire design details with drawings will be provided. Okay. So in production department, what they will do, so they will manufacture a gear by using some machines. Okay. So during the manufacturing process, so after some process like cutting the gear, cutting the gear, he will measure the pitch by using some instruments. Meanwhile, he will use the measuring instruments to measure the manufactured parts, right? So simple example you take, see if a student is required to turn a MS rod of 25 diameter, okay, 25 diameter to 23 diameter, okay. So in our labs, what we will do, we use lathe machine tool, right? So in lathe machine tool, the student will fix the MS steel rod of 25 diameter and he will start turning. Okay, so you need to turn the MS rod to 23 So you will make some turning process. Next, you will take vernier caliper. You will measure the diameter. Okay, if it is 24 again you will do turning process. So until we get 23 we need to turn. So meanwhile we are using measuring instruments, okay, to measure the manufacturing components. See, nowadays we are not in industries, they are not using instruments and all. Okay, they have coordinate measuring machines, so automatically the machine will check the dimensions of the manufacturing components. Coming to quality checking department, there they use many types of limit gauges, okay, like double-ended snap gauge and some measuring instruments. So in every department we need measuring instruments. So without measurements, it is impossible to get the economical design. Okay, economical design of equipment and process. So next, measurements are required for proper operation, control and maintenance of industrial processes. That is in processing industries. Okay, so the best example is we can consider steam power plants. Steam power plants. So in steam power plants, the steam boilers plays an important role. So without steam boilers, we cannot produce steam. So the steam boilers will be attached with some safety devices, okay, like pressure gauge, okay, some safety devices. So these safety devices will be controlled by some measurements. So in steam boilers they will provide level indicators, temperature monitoring devices. So there also measurements are very important. So next, say measurements are very useful in environmental monitoring. Example, to measure earthquakes. So we use seismograph or seismometers. So in earlier days they are using Richter scales. So nowadays we are using seismograph or seismometer to get the earthquake. Sorry, to measure the earthquakes. To measure the earthquakes. Okay. Next, to measure air velocity. So we use anemometers. Okay, to monitor environmental conditions or to get the temperature, humidity measurements. So we use measuring instruments. So the next point, measurements are used in fair trading and consumer protection, the domestic and international arenas. Arenas means in areas. Okay. So in fair trading, ವ್ಯಾಪಾರ ಅಂತ ಹೇಳ್ತೀವಲ್ವಾ. So buying and selling the goods. So in business, okay, in fair trading it is very important. In consumer protection, okay. So when we go to the stores, so we need some measuring instruments. A simple example, to measure the sugar in kgs. So weighing balance is used. To measure the milk in liters, so some devices will be used. Okay. So in fair trading and consumer protection in our daily lives, we will come across measurements. So see the seventh point, measurements are used to monitor a data in the interest of health and safety. When we go to hospitals, the doctor will use clinical thermometer, right? To check the temperature of a human body, he will use clinical thermometer. And to measure blood pressure of a human, they use sphygmomanometers, that is blood pressure devices. Okay. And for X-rays, for heartbeat. So many devices are there to check the health condition of a human being. Okay, so these are all the main points I have taken. There are many points. So the next slide. So let us move on to accuracy. So see, there are some terms related to measuring instruments, but the accuracy and precision plays an important role. Okay. So the terms related to measuring instruments are accuracy and precision, sensitivity, next repeatability, range, threshold, calibration. So in this session we are going to discuss accuracy. See, accuracy is defined as the closeness of agreement between a measured value and the true value. Closeness of agreement between a measured value and the true value. True value means the exact value. Okay. So how close the measured value is with the true value. So this says the accuracy. So next, precision. So see, it is the ability of an instrument. So see, this accuracy and precision is related to measuring instruments. These are the terms related to measuring instruments. Keep it in mind. So precision. So it is the ability of an instrument to reproduce. So this word is very important. Okay. While defining precision, You need to use reproduce. So it is the ability of an instrument to reproduce the certain reading with a given accuracy. So it is a repeatability of a measuring process. Okay, it is a repeatability of a measuring process. And also, see, precision is a degree of repetitiveness and refers to a group of measurements. See, precision is always referred to a group of measurements rather than a single measurement. Okay, rather than a single measurement. See, accuracy, it is considered with the single measurement, but coming to precision, it refers to a group of measurements. See, if we take the example, you will come to know so what exactly the accuracy and precision means. So I will give a simple example to see. So this is a example of guessing the age of a person. Guessing the age of a person. The person's age is 30 years. Okay, his age is 30 years. Here, what I will do, I will make 3 groups consisting of 4 students. Okay, so the group 1 has 4 students, the group 2 has 4 students, and the group 3 has 4 students. I will tell the students to guess the age of a person of a 30 years. So in group 1, one student will give 29 years and other student says 31 years and remaining 2 students they say 30 years. Okay, coming to group 2, here 3 students says 55 years, 55 years, 55 years and other remaining 1 student gives 54 years. Okay, and group 3, so one student will guess 25 years, guess the age as 25 years, other student 45 years, third student 60 years and other student 19 years. Okay, so coming to group 1, say 2 students has told 30 years. So this is the true value, right? So the actual age of a person is 30 years. Okay, 2 students guessed the age of a person correctly. So it is accurate. So other 2 students, so they said 29 years, 31 years. So group 1 is accurate because the 2 students has guessed 30 years. Okay, so this is the true value, right? So this is the true value. And whether they are precise, say these 4 readings, these 4 guessing the age, they guessed the age, so these 4 readings are nearer to each other. So I mean these 4 readings are nearer to the true value. So the true value is 30 years. The person's age is 30 years, right? The two students guessed the age as 30 years. Okay, that is right, that is accurate. So that is the true value. And other student 29 years. So he is 1 year, guessed the age as 1 year less, and another student guessed the age as 1 year more. So these 4 readings are nearer to each other. Means these 4 readings are very close to the true value. Okay, so I say group 1 students are accurate. I mean the group 1 students readings, what they have told, what they have guessed the age are accurate. So that is yes. Whether the readings are accurate, 29, 31, 30, 30, yes, they are accurate because see 30, 30. Precise, whether the 4 readings are nearer to the true value, yes, they are precise. See, when we place these readings to the dartboard analogy, we can see like this. See, here this is the target. Okay, So this is the target. So this is 30 years. Consider this as a 30 years. Okay. So 29, 29, sorry, 29, 31, 30, 30. So this is the target. So all readings are nearby 30 years. Okay. So I can say accurate. Yes. So these four readings are accurate, and also these four readings are nearer to each other. Yes, this is precise. So accurate and precise. So whatever the readings from group 1 are accurate and precise. So coming to group 2, 55, 55, 55, 54. Even not a single reading is nearer to the true value. Not even single student guessed the age nearer to the true value or exact age. So it is not accurate. Okay, but precise. Why? Whatever the age they have guessed, those readings are nearer to each other. See, 55, 55 years, 55 years, 54 years. They are not guessing the exact true age of a person, but all four students are giving the readings in around 55. Okay, so they are precise. The group of readings is precise, but it is not accurate. So coming to group 3, so see 25, 45, 60, 19. Not even a single student guessed the true age of a person, that is 30 years. So it is not accurate. Whether the four readings are very close to each other? No. One has guessed 25, 45, 60, 19. Four readings are far away. Okay, they are very totally different. So it is not precise. So exact value ನಿಮಗೆ ಟ್ರೂ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿ ಬಂದಿದೆ ಪರ್ಸನ್ ಏಜು 30 ಇಯರ್ಸು ಸೊ ಈ ಗ್ರೂಪ್ ಅವ್ರು ಮಾತ್ರ ಕರೆಕ್ಟಾಗಿ ಇಬ್ಬರು 30 ಇಯರ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ ಸೊ ಅದು ಟ್ರೂ ವ್ಯಾಲ್ಯೂ ಇದೆ ನಮಗೆ ಇಲ್ಲಿ ಸೊ ಅದು ಅಕ್ಯುರೇಟ್ ಮತ್ತು ಈ 4 ಜನ ಏನು ಮಾಡಿದ್ದಾರೆ ಕರೆಕ್ಟಾಗಿ ಗೆಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದರೆ ನಿಯರರ್ ಟ್ರೂ ವ್ಯಾಲ್ಯೂಗೆ ನಿಯರರ್ ಆಗಿದೆ ಓಕೆ ಸೊ ಪ್ರಿಸೈಸು ಸಹ ಹೌದು ಗ್ರೂಪ್ 2ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಯಾರಾದರೂ ಒಬ್ಬರಾದರೂ 30 ಇಯರ್ಸ್ ಗೆಸ್ ಮಾಡಿದಾರಾ ಇಲ್ಲ ಬಟ್ ಅವ್ರು ಗೆಸ್ ಮಾಡಿರೋದು 4 ಜನ ಏನು ಗೆಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅದು ಎಲ್ಲಾನು ಅವ್ರ ಗೆಸ್ಸಿಂಗ್ಗೆ ಎಲ್ಲ ನಿಯರ್ ಆಗಿದೆ 55, 55, 55, 54 ಅಂತ ಇದೆ ಸೊ ಅದು ಪ್ರಿಸೈಸ್ ಅಂದರೆ ಆ ರೀಡಿಂಗ್ಸು ಅದು ಆ ಗ್ರೂಪ್ ಅವರು ಆ ರೀಡಿಂಗ್ಸ್ ಎಲ್ಲ ನಿಯರ್ ಬೈ ಇದೆ ಬಟ್ ಅಕ್ಯುರೇಟ್ ರೀಡಿಂಗ್ ಒಬ್ರು ಗೆಸ್ ಮಾಡಿಲ್ಲ ನೋಡಿ ಹಿಂಗಿದೆ ಸೊ ದಿಸ್ ಈಸ್ ಎ ಟಾರ್ಗೆಟ್ ನಮ್ಮ ಟಾರ್ಗೆಟು ಇದು 30 ಇಯರ್ಸ್ ಇದು ಇಲ್ಲಿ ಒಬ್ಬರಾದ್ರೂ ಗೆಸ್ ಮಾಡಿದಾರಾ ಇಲ್ಲ ಹಿಂಗಿರುತ್ತೆ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಕೊಡ್ತಾ ಇರೋದು ಇದು ಇಲ್ಲಿ ಗ್ರೂಪ್ 3 ಅವ್ರನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಒಬ್ರು ಟ್ರೂ ವ್ಯಾಲ್ಯೂನ ನಮ್ಗೆ ಹೇಳಿಲ್ಲ ಒಬ್ರು 30 ಇಯರ್ಸ್ ಅಂತ ಗೆಸ್ ಮಾಡಿಲ್ಲ ಮತ್ತೆ ಅವ್ರು ಏನು ಗೆಸ್ ಮಾಡ್ತಿದ್ರೆ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಅದು ತುಂಬ ಡಿಫ್ರೆನ್ಸ್ ಇದೆ ಓಕೆ ಸೊ ಅದಕ್ಕೆ ಅಕ್ಯುರೇಟ್ ಆಗೂ ಇಲ್ಲ ಅವ್ರ ರೀಡಿಂಗ್ಸು ಪ್ರಿಸೈಸ್ ಆಗೂ ಇಲ್ಲ ಗೊತ್ತಾಯ್ತಾ ಸೊ ಟ್ರೂ ವ್ಯಾಲ್ಯೂಗೆ ಎಷ್ಟು ನಿಯರ್ ಆಗಿದೆ ನೀವು ಮೆಜರ್ ಮಾಡ್ತಿರೋ ವ್ಯಾಲ್ಯೂ ಅದು ಅಕ್ಯುರಸಿನ ಕೊಡುತ್ತೆ ಪ್ರಿಸಿಷನ್ ಅಕ್ಯುರಸಿ ಇಸ್ ಆಲ್ವೇಸ್ ರೆಫರ್ಸ್ ಟು ಎ ಸಿಂಗಲ್ ಮೆಜರ್ಮೆಂಟ್ ಬಟ್ ಪ್ರಿಸಿಷನ್ ಅನ್ನೋದು ಗ್ರೂಪ್ ಆಫ್ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಅದು ನೆಕ್ಸ್ಟ್ ಈಗ ಪ್ರಿಸಿಷನ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದೋ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಇದೆ ಸೊ ಸಿ ಕನ್ಸಿಡರ್ ಲೆಟ್ ದಿ ನೌನ್ ವೋಲ್ಟೇಜ್ ಆಫ್ 101 volts with a certain meter. We have some meter, okay, some electrical meter, and we know the voltage, so 101 volts. What we do to measure the precision of that instrument, we take 5 readings from that meter. So it is indicated as, see the actual value, the true value is 101 volts, but the instrument is giving 105, 104, 106, 104 and 106 volts. When we take the mean value, okay, so here we have taken a 5 reading, so the total is 525 divided by 5. So the mean value is 105. So how we can specify the precision of that meter, okay. So precision is plus or minus 1% because the maximum deviation So the maximum deviation is 106. So this is the highest reading the meter has given to us, right? But the true value is 101 volts. We know that. But it is indicating the maximum value is 106 volts. So that is the maximum deviation. The maximum deviation 106 from the mean reading 105 is only 1 volt. Okay, so that's why the precision of that instrument is plus or minus 1%. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? ನಮಗೆ ನೋನ್ ವೋಲ್ಟೇಜ್, ನಮಗೆ ವೋಲ್ಟೇಜ್ ಗೊತ್ತಿರುತ್ತೆ ನಮಗೆ ವೋಲ್ಟೇಜ್ 101 ವೋಲ್ಟ್ಸ್ ಅಂತ. ಯಾವುದೋ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಮೀಟರ್ ತಗೊಂಡು ನಾವು ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ತಗೊಂಡು ಸೊ ಆ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ 5 ರೀಡಿಂಗ್ಸ್ನ ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಆಗ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ? 105, 104, 106, 104, 106 ಅಂತ ಕೊಡುತ್ತೆ. ಸೊ ಅದನ್ನು ಮೀನ್ ತಗೋತೀವಿ ನಾವು. ಓಕೆ, ಆವ್ರೇಜ್. ಸೊ ಆವ್ರೇಜ್ ತಗೊಂಡಾಗ ನಮ್ಗೆ ಏನು ಬರುತ್ತೆ? 105 ಅಂತ ಬರ್ತಿದೆ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿವಿಯೇಷನ್ ಅಂದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೀಡಿಂಗ್ ಯಾವ್ದು ಕೊಟ್ಟಿದೆ? ಸೊ ಯಾವುದಿಲ್ಲಿ 106 ವೋಲ್ಟ್ಸ್, ಮೀನು 105. ಎಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ? 1 ವೋಲ್ಟ್ ಇದೆ. ಸೊ ಪ್ರಿಸಿಷನ್ನು ನಮಗೆ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 1% ಅಂತ ಹೇಳ್ಬೋದು. ಆ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ನ ಪ್ರಿಸಿಷನ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 1%. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ಪ್ರಿಸಿಷನ್ ನಾವು ಡಿಸೈಡ್ ಮಾಡಬೇಕು ಅಂದರೆ ಸೊ ಗ್ರೂಪ್ ಆಫ್ ರೀಡಿಂಗ್ಸ್ ಇರಲೇಬೇಕು. ಅಲ್ಲಿ ತುಂಬ ಟೈಮ್ ತಗೊಂಡಾಗ, ತುಂಬ ರೀಡಿಂಗ್ಸ್ ತಗೊಂಡಾಗ ಮೆಷರಿಂಗ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ ಸೊ ನಮಗೆ ಎಷ್ಟು ಪ್ರಿಸೈಸ್ ಆಗಿದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ನೋಡಿ, ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಸಿ, ಲೆಟ್ us consider the dartboard analogy. Okay, so to differentiate precision and accuracy. So see, imagine a person throwing darts trying to hit the bull's eye. So this is our target, red color mark, right? So these are the arrows. If the arrows reach this target, red color point, so that is accurate. Okay, this is our target. Our arrows should reach this target. But here consider this dartboard. The person threw 3 arrows. Okay, 3 darts. See here. So one hit here, other here, and another here. So neither accurate nor precise. Not even a single dart reached this target. Next, you see 3 darts are nearer to each other, right? It is all these 3 are in the same place, but not even a single dart reached the target. That's the bullseye. Okay, but 3 dots are in the same place. So what we can say? So this is not accurate but precise. Why it is not accurate? Because even not a single arrow or dart reached the target. It is not here. So all 3 are farther to this target, but in the same place. All 3 dots are in the same place. It is precise but not accurate. Precise, see, but not accurate. See, precise and accurate. So all 3 dots reached the target, right? ಪ್ರತಿ ಒಂದು ಡಾಟು ಇಲ್ಲಿದೆ, ನಮ್ಮ ಟಾರ್ಗೆಟ್ ಹತ್ರ ಇದೆ, ಮತ್ತು ಎಲ್ಲಾನು ಹತ್ರವಾಗೇ ಇದೆ. ಸೊ ಪ್ರಿಸೈಸ್ ಆ್ಯಂಡ್ ಅಕ್ಯುರೇಟ್ ಹೀಗೆ ಹೇಳ್ತೀವಿ. ಇದು ಅಷ್ಟೇ, ಸೇಮ್ ಡಯಾಗ್ರಾಮು. ಇಲ್ಲೊಂದು ಎಕ್ಸ್ಟ್ರಾ ಇದೆ. ಸೊ ಪ್ರಿಸೈಸ್ ಆ್ಯಂಡ್ ಅಕ್ಯುರೇಟ್ ಎಲ್ಲಾನು ಇಲ್ಲಿ ರೀಚ್ ಆಗಿದೆ. ಇದು ನಮ್ಮ ಟಾರ್ಗೆಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ, ಇಫ್ ವಿ ಕನ್ಸಿಡರ್ ದಿಸ್ ಆಸ್ ಅವರ್ ಟಾರ್ಗೆಟ್, ಸೊ these are the readings. Just consider these are the readings. So here this is precise and accurate. So this is precise but not accurate. So this is the target. So not even single reading is not there here. So it is far away, but all are near to each other. So precise but not accurate. accurate but not precise. Even some two readings reached the targets, reached the true value, but remaining measurements are not nearer to the true value. So accurate but not precise. So this is neither precise nor accurate. Okay. So see, accuracy is defined as the closeness of agreement between a measured value and the true value. How close a measured value is with the true value gives the accuracy. ಸೊ ಯಾವುದೋ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ತಗೊಂಡು ನೀವು ಮೆಷರ್ಮೆಂಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಇನ್ಪುಟ್ ಮೊದಲೇ ನಿಮಗೆ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿರುತ್ತೆ, ಫಸ್ಟೇ ಗೊತ್ತಿರುತ್ತೆ ಎಷ್ಟು ಅಂತ. ಈಗ ಫಾರ್ ಓಕೆ, ನಿಮ್ಮ ಮೆಷರ್ಮೆಂಟ್ ಯಾವುದೋ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ತೊಗೊಂಡು ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ, ನೋನ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿರುತ್ತೆ ನಿಮಗೆ. ಮೆಷರ್ ಮಾಡಿದಾಗ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಏನೋ ಸ್ವಲ್ಪ ಡಿಫ್ರೆನ್ಸ್ ಕೊಡುತ್ತೆ ಟ್ರೂ ವ್ಯಾಲ್ಯೂಗಿಂತ. ಸೊ ಎಷ್ಟು ಕ್ಲೋಸ್ ಆಗಿದೆ ನಿಮಗೆ ಗೊತ್ತಿರೋ ವ್ಯಾಲ್ಯೂಗೆ ಮತ್ತು ಮೆಷರ್ಡ್ ವ್ಯಾಲ್ಯೂಗೆ, ಸೊ ಅದನ್ನು ಅಕ್ಯುರಸಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಕ್ಯುರಸಿ ಇಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ಎ ಕ್ಲೋಸ್ನೆಸ್ ಆಫ್ ಅಗ್ರಿಮೆಂಟ್ ಬಿಟ್ವೀನ್ ಎ ಮೆಷರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಅಂಡ್ ದಿ ಟ್ರೂ ವ್ಯಾಲ್ಯೂ. ಸೊ ಟ್ರೂ ವ್ಯಾಲ್ಯೂಗೆ ಮೆಷರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಕ್ಲೋಸ್ ಆಗಿದೆ, ಎಷ್ಟು ನಿಯರ್ ಬೈ ಇದೆ, ಅದು accurate. See, always the measuring instrument should be accurate. Precision ಅಂದಾಗ, so it is the repeatability of a measuring process. Ability of an instrument to reproduce the certain reading with a given accuracy. ನೀವು ಯಾವುದೋ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ 30 ಸೆಂಟಿಮೀಟರ್ ಅಂತ ತೋರಿಸುತ್ತೆ. ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್ ತಗೊಳ್ಳಿ ಈಗ. ಓಕೆ, ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್. ಓಕೆ, ಒಂದು 20 ಫಸ್ಟ್ ಯಾವುದೋ ಒಂದು ಮೆಷರ್ಮೆಂಟ್ ತಗೋತೀರ, ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್, ಸ್ಮಾಲ್ ಆಬ್ಜೆಕ್ಟು. ಸೊ 20 mm ತೋರಿಸುತ್ತೆ. ಓಕೆ, ಫಸ್ಟ್ ರೀಡಿಂಗ್ ಇಸ್ 20 mm. ಸೊ ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಅದೇ ಆಬ್ಜೆಕ್ಟೇ ಯೂಸ್ ಮಾಡ್ತೀರಾ, ಅದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟೇ ಯೂಸ್ ಮಾಡ್ತೀರಾ, ಮತ್ತೆ 20 mm ತೋರಿಸ್ಬೇಕು. ಅದು ಇಲ್ಲ 21 ತೋರಿಸ್ತು, ಇಲ್ಲ 19 ತೋರಿಸ್ತು, ಮತ್ತೆ 20 mm ತೋರಿಸ್ತು. ಓಕೆ, ಸೊ ಆ ಥರ ಡಿಫ್ರೆನ್ಸ್ ಇರುತ್ತೆ. ಬಟ್ ಯಾವಾಗ ಸೇಮ್ ಅದೇ ಆಬ್ಜೆಕ್ಟ್ ಯೂಸ್ ಮಾಡಿ, ಅದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಯೂಸ್ ಮಾಡಿ ನೀವು ಮೆಷರ್ಮೆಂಟ್ ತಗೊಂಡಾಗ ಅದು ಸೇಮ್ ರೀಡಿಂಗ್ಸ್ನ ರೀಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇರಬೇಕು. ಫಸ್ಟ್ ಒಂದ್ಸಲ ತಗೋತೀರ, ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ತಗೊಂಡು ಮೆಷರ್ಮೆಂಟ್ ಮಾಡ್ತೀರಾ. ಸೊ ಮಾಡಿದಾಗ 20 mm ಕೊಡ್ತು. ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಅದೇ ಮೆಷರಿಂಗ್ ಪ್ರೊಸೆಸ್ನ ನೀವು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀರಾ, ಮತ್ತೆ 20 mm ತೋರಿಸ್ಬೇಕು, ಮತ್ತೆ 20 mm, ಮತ್ತೆ 20 mm. ಸೊ ಲೈಕ್ ದಟ್. So the ability of an instrument to reproduce a certain reading with a given accuracy. Okay, so same measurements instrument na ತಗೊಂಡು ಮೆಷರ್ಮೆಂಟ್ ಮಾಡಿದಾಗ ಸೇಮ್ ಅದೇ ರೀಡಿಂಗ್ಸ್ನ ಅದು ರೀಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇರಬೇಕು. Okay, so that is nothing but precision. The ability of an instrument to reproduce, this word is very important, keep it in mind, to reproduce the certain reading with a given accuracy. So accurate ಆಗೂ ಇರಬೇಕು. Okay, so this is about the session 2. So we covered significance of measurements, definition of accuracy, definition of precision, difference between precision and accuracy. Okay, thank you.